Hello and welcome to the lecture series on power electronics. In today's lecture, we would be seeing the operation of 180-degree mode of conduction in a three-phase inverter. So let us start. So I told you in the previous lecture that basically there are two modes of operation for a three-phase bridge inverter configuration. One is called the 180-degree conduction mode. The other one is the 120-degree conduction mode. The basic difference between the two conduction mode is that is because of the duration for which each of the switch conducts. So in 180-degree conduction mode, each of these switches 1, 3, 5, 4, 6, 2 they conduct for 180 degrees, while in case of 120-degree conduction mode they conduct for 120 degrees. So that's the basic difference. So let us now try to analyze this circuit for 180-degree conduction mode. This is our three-phase inverter. So 1, 3 and 5 basically refers to the switches. So this is basically a switch. It could be on or off depending on the firing signal given to it. Okay, I have drawn the firing sequence for the switches. I had told you in the previous lecture that what is the sequence for the firing of the 6 switches. So the first switch is turned on at say 0 degrees, then it has to conduct for 180 degree. That means the gate pulse provided to it should be a pulse of width duration pi, and it should start from 0 and it will end at pi. Okay, and from pi to 2 pi there won't be any signal given to the switch 1, and again from after 2 pi again the signal will be given for 180 degrees. Okay, similarly the second switch is given firing pulse at 60 degrees at pi by 3. This is your pi by 3. Okay, and it lasts till this is 180 plus 60, it is 240 degrees. Okay, so better to represent it in degrees so that converting it or representing it in radians sometimes it becomes difficult to represent. Okay, so this starts from 0 degree and this is for 180 degrees. The second signal to the second switch is given at 60 degrees and it is continued till 240 degrees. Third switch is given the firing pulse at 120 degrees and it continues till 300 degrees. Similarly, fourth switch is given firing pulse at 180 degree and continues till 360 degrees. Then the fifth pulse is given firing signal at 240 degrees and it continues till 420 degrees. Then sixth signal is given firing pulse at 300 degrees and it continues conducting till 480 degrees. Okay. Now let us see how we obtain the phase voltage and the line voltage. I have shown the waveform for a single phase only. We can extend it for the other two phases also. We can obtain the waveform for other two phases also. Just you have to shift the waveform by 120 degree to the right for the two phases respectively. Okay, so let's start by looking into the circuit. One more thing that I have shown here is for each of these states, these are 6, 1, 2, 3, 4, 5, 6, and here the cycle is complete. Cycle is complete. So each of these step, in each of these step, 3 switches are conducting. Okay, so you could see 5, 6, 1, and in next step 6, 1, 2, 1, 2, 3, 2, 3, 4, and so on. How we obtained this switching pattern? Okay, I had told you that just write down like this: 1, 2, 3, 4, 5, and 6. So 1, 2, 3 would be conducting in the first step, then 2, 3, 4 would be conducting, then 3, 4, 5 would be conducting, then 4, 5, 6 would be conducting, then 5, 6 and 1 would be conducting, and each of them would be conducting for 60 degrees. Okay, fine. Now let us see, let us actually look into how we obtain this waveform. Okay. So let us start with the first step. In step 1, 5, 6 and 1 switches 5, 6 and 1 are conducting. That means I have to close this 5, this 6 and 1. 5, 6 and 1. Okay. So if that is the case, let me draw the circuit, simplified version of the same circuit. Okay. So let me start from this point. Let me call this point as what I call, say this is plus point and this is minus point. Okay. So we have got this VDC here, and then this is your plus point and this is your negative point. Okay. Then I have to go through 2 paths here. Okay. Just see, from 1 and from 5. Okay. And from 1 and from 1 and through point A, this is point A, and then to these 3 points. Let me name them also. So let me call this as capital A, this as capital B, and this as capital C. So from A to then capital A, and then there is a resistor here, and then to point N. Okay. And now you could see that at point N there is a bifurcation. So there is a resistor here also and a resistor here also. This is getting connected to point B and this is getting connected to point C. Okay. And from C it goes to small c. So let me make it big. This is a small c, and from C through 5 it is coming back to V positive. So this point is basically or let me first draw this. Okay. Or let me take for otherwise there would be crossing of the lines. So let me take C here, C and B here. Okay. It does not matter. So B is here, small b is here, this is capital B, then small b, and then through 6 it is coming to minus point. It is coming to the minus point. Okay. And finally through C, capital C, and to small c, and then it is basically coming back to point plus positive, this point. Okay. So I can rather show this as in this way. So this is C point, then small c was there, and then we are coming back to this plus point. Okay. Fine. And this is your neutral point. So now let us now try to find out the current that is flowing in the circuit. Okay. So these two resistances are in series. So if they are in series, the equivalent resistance would be R by 2. So this is R by 2, and then it is in they are in parallel, not in series. R and R, they are in parallel. So the combination of them would be R by 2, and then it is in series with R. So this is the simplified version, more simplified version. This is R, and if I add these two, then again this resistance become finally R plus R by 2, that means 3R by 2. So this is VDC and this is 3R by 2. The current that would be drawn from VDC would be VDC, the current I, the source current IDC equals to VDC upon 3R by 2. Okay. So, this is the current flowing from this point. Now, we are interested in finding out VAN. So, that means I need to know what is the current that is flowing through this branch. Okay. So, what is the current flowing here and here? So, since the current that is coming from the battery is 2 VDC by 3, and since it is equally being divided here because these two are R and R. So, that means VDC by 3 will go here and VDC by 3 will go in this branch, and then finally they will combine here, and finally this would be 2 VDC by 3. So, what is the voltage drop here? That would be VAN. So, VAN is equal to, you see the current that is flowing here is VDC by 3 R. Sorry, I have missed R here. So, R would also be there, R is there. So, VDC by 3 R, then this has to be multiplied by this R. Okay. So, that means VAN will be given by VDC by 3. Fine. So, you could see here that I have mentioned this first step. So, this is VDC by 3. Okay. Now, what about the line voltage VAB? So, that means this voltage from here to at this point. Okay. Let us try to find it out, that also. Okay. So, let me start from this point. Let me call this as VA, and then there is a drop here. So, since I am going in the direction of the current, so minus of the drop. So, drop is VAN. So, this is VAN, and then there is a drop here also, or just let me write down the values itself. So, the current that is flowing here is VDC by 3R, and that has to be multiplied by the resistance R, and then the drop here is again minus, and the current is 2 VDC by 3R. This has to be multiplied by R, and then this equals to VB. So, that means let me bring this VB this side and rest of the thing on the right side. So, VAB, which is equal to VA minus VB, and this is equal to, if you add these two, so 2 VDC by 3 and VDC by 3. So, finally, it becomes VDC. So, VDC and R gets cancelled. Okay. So, the line voltage between A and B is given by VDC. So, that is what I have mentioned here. Okay. So, it is VDC. Similarly, let me take up one more state, and let us try to analyze it. So, in the next state, 6, 1 and 2, the switches 6, 1 and 2 are conducting. So, let me just remove these green lines from here, and now 6, 1, 2. So, 1 would be conducting, and then 2 would be conducting, and then 6 would be conducting. Now, 5 is not conducting. Okay. Fine. Now, let us try to draw this circuit. I mean simplify this circuit. So, let us start from the VDC. This is VDC, and this is the plus point, and this is the minus point. So, here you could see that I have to go through this point A to then capital A, and then at this point we have got this resistance R, and then it gets bifurcated into two parts. Okay. And just see this, there are two parts. One is your B, the other one is your C, capital C, and then to small b, and then to small c, and finally you could see that both of them are combining and coming to the point minus of VDC. Okay. So if that is the case, again similar situation, the current that would be flowing here, we found it out in the previous case, it would be the current that would be drawn from here. So actually the sum of these two these two are in parallel, the equivalent of these will be R by 2, and you have to add it to R. So if you add it to R, again you get this R, 3R by 2, and the current that would be flowing would now be VDC upon 3R by 2. So this is the current that is flowing here, 2 VDC upon 3R, and that gets bifurcated, VDC by 3R flow here, VDC by 3R flow here. Now let us first try to find out, this is the point N, let us try to find out VAN. So VAN is bit simple here, VA capital N is equal to, VAN is the current that is flowing through it is 2 VDC upon 3R, and this has to be multiplied by the resistance, this R, and this will give me 2 VDC upon 3. This is the phase voltage. So you could see here that I have shown this phase voltage in the second state as 2 VDC by 3. Now let us see what would be VAB. VAB. So for VAB I have to travel from this point to this point, okay, and again similar situation is there. So let us start from this point VA minus, and the drop here which is 2 VDC upon 3R is the current into resistance. So this is the drop here at this resistance, then I have to go at this point, so again minus of VDC upon 3R, and this has to be multiplied by the resistance R, and then finally I reach this point VB, and finally if you simplify it you will get VAB is equal to VDC again. Okay. So that means again VDC, just see here, this is plus VDC, so you could see here, fine. So let me just take up just one more state, and that is a bit different because VAB is coming to be 0 in that case. So let me just rearrange it. So now 1, 2 and 3 are conducting, 1, 2 and not 6, but the switch 3 is conducting. So if that is the case, let me again quickly draw the circuit here. So this is VDC and this is plus and minus point. Let us start from this point. So these two point, it is basically point B, and then it is basically bifurcating at this point. Okay. So there is a bifurcation here, and this is point B and this is point A. Point B gets connected to R, A also gets connected to R, and then finally they are converging at N, and then going to this point small c, and then to capital C, and then finally coming back to the point minus VDC. Okay. So what is the voltage? First of all we have to find out the current that is flowing. Similar case, R, and R. So the current that will be flowing from the battery would again be 2 VDC upon 3R. So that would be the current that will be flowing from the source. So I have to find out this VAN. So current gets bifurcated here. So the current that would be flowing here would be VDC upon 3R. So if I have to multiply with R, so VDC upon 3R, if it is multiplied by R, will give you VAN, and that is equal to VDC by 3 that I have shown here, VDC by 3 again. What about VAB? VAB, you could see here that VAB are the same point. So the potential across them is equal to 0. So there is no potential here. And similarly, you can complete for the entire cycle, okay, just by redrawing the circuit with the switch that is on and opening the switch which is off, okay. So this is the waveform. We will try to analyze the waveform, and we would also see the advantages and the shortcomings of 180-degree conduction mode in our next lecture. Thank you for watching.